In today's video, we'll be studying the male reproductive system. And here we have the outline of all we'll be studying. Now, first on our list is the scrotum. The scrotum is a pouch of skin outside the male body, just as we have in this picture. The scrotum helps to keep the testis outside the body. Now, why is the scrotum so important? It's good for us to take note of the fact that sperm production is optimal at 34 degrees Celsius. Okay, however, the normal body temperature is about 37 degrees Celsius. It means that for sperm production to take place optimally, the testes have to be at a lower temperature than the body temperature. Now, here is where the scrotum comes to play, because the scrotum helps to keep the testis outside the male body and keeps it at a lower temperature than the body of the male. Okay, now here in the scrotum, as I said earlier, we have the testis, and holding the testis in the scrotum is the spermatic cord. Okay, the spermatic cord. Now, a muscle called the cremaster muscle forms part of the spermatic cord. Now we have what we call the cremasteric reflex. This cremasteric reflex helps to retract the scrotum or the testis to the male body when there is a decrease in temperature. So when there is a decrease in temperature such that the temperature goes to about 32 degrees Celsius, okay, the testis would need to gain some heat from the human body in order to raise its temperature to 34, which is the optimal temperature for sperm production. And so this cremaster muscle retracts or contracts, and by contraction, it retracts the testis closer to the human body so it can gain some heat. Okay. The next structure we'll be considering is the testis. Now, the testis, as we can see in the picture here, is an oval structure, okay, and it's a gland, meaning that it produces hormones. The particular hormone we'll be considering for this video is the testosterone. Now, the testosterone is the principal sex hormone in males, and it helps in the development of secondary sex characteristics at puberty. Okay, now coming back to the testis, as we can see here, is this oval structure, and it also helps in sperm production, which is the male sex gamete. Okay, the next structure we'll be considering is the seminiferous tubules. Now, as we have them here in this picture, the seminiferous tubules are highly convoluted tubules that are in the testis. Okay, now it is in the seminiferous tubules that sperm is being produced. Here we have them in this diagram as these highly convoluted tubules. Convoluted is simply a fancy word for highly coiled. Okay, so the seminiferous tubules are highly coiled, and it is within the seminiferous tubules that sperm is produced. Next structure we'll be considering is the epididymis. Now, the epididymis is another coiled tubule that we have in the scrotum. However, unlike the seminiferous tubules, the epididymis is not as coiled. Okay, so we have the label for the tail of the epididymis right here. Now, the epididymis is the structure that stores immature sperm. So when the sperm is produced within the seminiferous tubules, they are transported to the epididymis where they are stored until maturation. Okay, connected to the tail of the epididymis is the vas deferens or the ductus deferens, which is the next structure we'll be considering. Now, the vas deferens is this tubular structure that carries mature sperm from the tail of the epididymis down to the ejaculatory duct. Okay, now the immature sperm is gotten here from the seminiferous tubules. It gets mature in the epididymis, and then from the epididymis it is taken through the vas deferens to the ejaculatory duct. The ejaculatory duct, as we can see here, is formed by the merging of the seminal duct, okay, the duct from the seminal gland, and the vas deferens or the ductus deferens. So the vas deferens as well as the duct from the seminal gland merge together to form the ejaculatory duct. And the ejaculatory duct passes through the prostate gland. It picks up the fluids produced by the prostate gland, and these fluids would combine together to form the semen, okay, as we would see. And the semen is simply the penile ejaculate. Also very important is the fact that the ejaculatory duct merges, as we can see here, with the urethra. Okay, the ejaculatory duct merges with the urethra from the urinary bladder. Now, when we were considering the female reproductive system, we saw that for the females, they have a vaginal orifice as well as the urethral orifice. And we stated that women pee from a different orifice and menstrual flow passes through a different orifice. However, for men, as we can see here, the ejaculatory duct is connected to the urethra, meaning that the penile ejaculate or the semen passes through the urethra as well as urine. Okay. Now, the next structure we'll be considering is the urethra. Now, the urethra is this tubular structure that comes from the urinary bladder. The urethra passes through the penis and also serves as passage for semen as well as urine. Alright, the next structure we'll be considering is the penis. Now, from the diagram here, we can see that the penis is the external genitalia of the male, and the penis is made of spongy tissues. It's made of these spongy tissues. The penis itself is an erectile organ. Okay, now when during erection, the spongy tissues are supplied with blood. Okay, the spongy tissues are supplied with blood, and this blood fills the spongy tissues and causes for the penis to be erect. Okay, and this is of course during sexual excitation. As we can see here in this diagram, the urethra that was earlier considered is surrounded by the spongy tissues. Now, during erection, at the bladder here, we have a sphincter muscle. Now, this sphincter muscle is what keeps the bladder shut. That's why when we have urine in the bladder, the urine doesn't just flow out through the urethra. There's a sphincter just at the neck of the urinary bladder that shuts the bladder in place until we are ready to pass out the urine. Now, during erection, what happens is that this sphincter is closed shut. Okay, it's closed shut for two reasons. It's closed shut so that urine and the semen do not pass out together, and it's also closed shut so that the semen coming from the ejaculatory duct does not flow into the urinary bladder. Okay, so during ejaculation, or rather during ejaculation as well as during erection, the probability of semen and urine to flow out together is very low because this sphincter is closed shut during erection. And the next structure we are to consider is the prostate gland. But before we consider the prostate gland, let's take a look at semen. Now, semen is simply the penile ejaculant, and ejaculation is the release of semen from the penis. Okay, now semen is a combination of both sperm and seminal fluids. These seminal fluids come from the seminal gland, it comes from the prostate gland, the bulbourethral gland, which is also called the Cowper's gland. All of these fluids form the seminal fluids, and the combination of the seminal fluid with the sperm is what forms the semen. Okay, now let's take a look at the prostate gland. On taking a look at the prostate gland, we can see that we have the ejaculatory duct and the urethra passing through the prostate gland. Okay, now the prostate gland is important because it helps to produce certain proteolytic enzymes that break down clotting factor. Now, what is the clotting factor and why is all of this so important? Now, it's good for us to take note of the fact that semen is alkaline. Semen is alkaline in nature, and sperm thrives in this alkaline environment of the semen. However, the female vagina is acidic. And during ejaculation or during sexual intercourse, the semen as well as the sperm is released into this acidic environment. Okay, now, of course, it would be expected that this acidic environment of the vagina would be harmful to the sperm. Now, what happens is that as the semen is being released, there is a form of protective gel that surrounds it, that encapsulates it, okay, that encapsulates the semen, protecting it or serving as a shield from the acidity of the vagina. And quickly the semen and the sperm gets to the cervix, where the acidity of the environment is relatively accommodating. Now, this gel that is produced to secure the sperm can be likened to clothing. Okay, clothing, just encapsulating the semen and the sperm together. Now, what the prostate gland does is that it produces these enzymes that help to break down the gel. So we have the semen within this gel. The gland or the prostate gland produces these enzymes that break down the gel, allowing for the sperm to now flow freely when it has got into a more accommodating environment in the female reproductive tract. Okay, it also produces certain fluids that nourish the sperm, so it's of importance in the male reproductive system. It's also one of the glands that of course produces part of the seminal fluid. The next structure we'll be considering is the bulbourethral gland. The bulbourethral gland is also called the Cowper's gland, and it produces what we call the Cowper's fluid. Now, urine is generally acidic, and as I stated earlier, the sperm and the semen is alkaline in nature, so sperm thrives in this alkaline environment. Now, before ejaculation, this Cowper's fluid is released. This Cowper's fluid is sometimes called the precum. It's called a precum because the semen is sometimes called cum, and since it comes before the flow of semen, it's called the precum. Now, this Cowper's fluid helps to kind of neutralize the acidity of the urine, because both the semen and the urine flow through the urethra. Okay, now it neutralizes the acidity of the urethra area, allowing it to be more accommodating for the passage of semen. Okay, that's the function of the bulbourethral gland. It's a mucus gland. It also lubricates the urethra in general, and of course neutralizes the acidity of the urethra as well. The next structure we'll be considering is the seminal gland. The seminal gland is what produces most of the part of the seminal fluid. Okay, and of course it's very important because it helps to keep the sperm, providing it with more fluidity, an ability to travel and be transported through the female reproductive tract. Now, something we omitted was when we were discussing the vas difference. Now, this of course is an abnormality in men with cystic fibrosis. Men with cystic fibrosis are sometimes born without the vas difference, and this is a cause of infertility in men. However, these men that are born without the vas difference are not completely sterile, because as we can see, sperm is produced within the testis in the seminiferous tubules, and maturation takes place here in the epididymis. However, this sperm that is being produced is unable to be transported to the ejaculatory duct. And since it's unable to be transported to the ejaculatory duct, it means that it's unable to leave the body of the male. Okay, so it's a cause of infertility, but it's not sterility entirely. Okay, now according to our outline, we have come to the end of the video. If you liked this video, please subscribe and give it a thumbs up. Thank you for watching till the end. Bye.